This is a help video for Math Quiz 1.07, Prime Factorization and Greatest Common Factors. Question number 1 says, which expression shows the prime factorization of 36? I'm going to show you how to do this using a factor tree. We start with the number 36 at the top. Then we think of what are some factors of 36. I'm going to start with 6 and 6. 6 times 6 is 36. Well, those are not prime, so I have to think of factors of 6. Well, factors of 6 are 2 and 3. And factors of 6 are 2 and 3. Now, all of my numbers at the bottom of the factor tree are prime numbers. So if we multiply, when we multiply 2, we're going to organize them lowest to highest. When we multiply 2 times 2 times 3 times 3, we should get 36. So that's how you would do your factor trees and get your prime factorization for question number 1. Question number 2 asks you, what is the prime factorization of 45? So I'm going to start with the number 45, and I am going to think of numbers that are factors of 45. Well, I can start out with 5. I know it's divisible by 5 because it ends in a 5. Right? 5 and what? 15? No. 5 times 9. 5 times 9 is 45. Oh my goodness. 5 times 9 is 45. Okay. Now I'm not done yet because I only have one prime factor here. I need to factor my 9 in 3 times 3. Okay, now I have prime factors all at the bottom of my factor tree. Question number 3 will give you two numbers and ask you what is the greatest common factor. Now we can use our prime factorization trees the same way to find our greatest common factor. The first thing I want to do is I want to find the prime factors of 24. Okay, well I know that it's divisible by 2, and 2 is a prime number. So that would be 2 and 12. So this is prime now. Factors of 12 are 2 and 6. Okay, no, that's prime now. And factors of 6 are 2 and 3. Alright, now I have all these prime numbers at the bottom. Now let's add our factor tree. Let's try 44. Well, I know that that's divisible by 2, and 2 is a prime number. 2 and 22. I'm already here with prime number. What is factors of 22? Well, I know that that's 2 and 11. Look there, I have prime numbers all at the bottom of my factor tree. Now I have to see which numbers they all have in common. So I'll start circling. They have 1 2 in common. They have 2 2's in common. But they don't have any other numbers I can match up. So I know that if I multiply 2 times 2, okay, they have 2 2's in common, I'm going to get 4, and that is my greatest common factor. Remember, you have to match up how many numbers they have in common. They have 2 2's in common, so I'm going to multiply 2 times 2. question number 4 asks you the same thing. So you make your prime factorization, you do your factor tree of 28 and 42. Okay, I'm going to start with, let's see, 2 and 14. I'm going to start you out here with 42. I know 6 and 7. Okay, you take it from there, and once you get your prime factors worked out, you have to match them up. Okay, all right, let's start matching them up. Here's our 2 and our 7. Now we multiply those together. Oops. 2 times 7 equals what? And that would be your greatest common factor. This gets you a couple, this takes it the other way. Which two numbers have the greatest common factor of 2? Well, if I were you, I would just start and make up factor trees of 6 and 12 and see what the greatest common factor is there, and 4 and 6, and 3 and 9. So you make factor trees from all of these and see which one has the greatest common factor of 2.